Hey guys, this is going to continue our lesson from the previous video on identifying the characteristics of linear functions. And so this should be where we left off in that video. So yesterday, or in the earlier parts of this lesson, we learned how to identify slope and y-intercept from a graph, and how to identify slope and y-intercept from an equation. And on a graph, remember, we did that by finding where it crossed the y-axis to get the y-intercept, and to do rise and run to find the slope. In an equation, we looked for the value in the m position of the mx plus b equation to find slope, and we looked for the value in the b position, or the number that was by itself, to find y-intercept. Now we need to look at how to do that from a table, and this gets a little bit tricky in some situations, because to find rate of change or slope on a table, you've got to be able to look at how the table is changing as far as a pattern is concerned. So if they tell you that the table is linear and they ask you to just find the slope and y-intercept, to find the slope, you just need to pick 2 points from your table to work with. You don't have to go all the way down the table like we did when we were doing deciding if it was linear or not. You can just pick 2 points, whatever 2 points you feel like are easiest for you to work with, and you're going to find the amount of change on those on both sides. So like for this first table, I might pick 4 and 5 and the 1 and 2 that go with them. So 4 and 5 have a change of increasing by 1, and when the x increases by 1, the y side increases by 1 also, because 1 to 2 is an addition of 1, from 4 to 5 is an addition of 1. So to get the slope from that, I take the change from the y side and I divide it by the change from the x side. And 1 divided by 1 gives me a slope of 1. So the m for this table is 1. Now the b for this table gets a little bit tricky, because the b value, remember, is the value where the x is 0. It's what happens when you cross that y-axis. And if you think about that, any point on the y-axis has a coordinate of 0, comma, some number. So on a table, we need the value where the x is 0. Well, this table doesn't show me that. It starts at 4, and then it goes 5, 6, 7. It never shows me 0 on the side that is x. But we have a pretty simple pattern going on of adding 1 every time. So it would be very easy for me to back up and find where the x is 0. So what we do with that is we say, okay, if at 4 we're at 1, then at 3, I know I would be at 0. At 2, so I'm just backing up the table here really, I would be at -1, because I'm backing this pattern up. At 1, I would be at -2. And at 0, I would be at -3. So I'm just letting that pattern continue. Add 1, add 1, add 1, add 1, add 1, add 1. And then same thing on this side. Once I hit that point where the x is 0, that is my b, -3. Let's look at the same thing on this next table. So in the next one, we'll do the same exact thing. We're going to look at our change on our x's, look at our change on our y's. Now, when I look at this, I might not love negative numbers. Now, I don't honestly have a problem with them, but for you as a student, negative numbers may not be your favorite thing. So if you'd rather work with these two instead of this up here that's negative, do that. It does not matter which two you work with. So if I work with 7 and 15, to change from a 7 to a 15, I add 8. We're always looking at what we would add to change it. To change from a 2 to a 10, I would add 8. So to calculate my slope, I divide the change on the y, 8, by the change in the x, 8, and 8 divided by 8 is 1. So the m, or the slope of that table, is 1. Now the b is going to be the point where x is 0. Now again, I've got a table that doesn't show me that. The difference here, though, is that 0 is not going to extend up the table like it did here. For here, I could go 4, 3, 2, 1, 0. Here, I can't go from -1 back to 0 that way. 0 falls between -1 and 7. But I can still figure out what it would be based on my rate of change. So if I think about 0 could be here, right after -1. And I know my change is 1. This is my slope. That's my rate of change. That 1 tells me that every time my x goes up 1, my y goes up 1. So if it was at -6, it would move to negative 5. Just increases by 1 because my rate of change is 1. So my B would be negative 5.
13 points.
All right, let's do another one. So in this one, again, we're going to look at our x and our y. Our x is changing by 1. Our y is changing by 10. So to figure out my rate of change, I'm going to divide the change in my y by the change in my x. So it increases by 10, increases by 1. So 10 divided by 1 is 10. So the slope of this line is 10. Now this one's going to be a little bit easier than the last one was to find our b, because this one's got a pretty simple table that we can kind of extend and work on. I'm going to put that back black because I wanted it to be black. I'm going to upload these notes later if y'all are wondering why I'm worrying about the color. M equals 10. So the b in this table, we can extend the table back, because if we're at 2, it'd be very easy for me to go from 2 to 1 and then from 1 to 0. So if I do that and I keep the table going back according to this pattern, if it was increasing by 10 to go this way, I'm going to decrease it by 10 to back it up. So 10 less than 20 would have put us at 10 here. 10 less than that would have put us at 0 here. So you see how that pattern continues to go. I go 0, 1, 2, 3, 4, 5, 0, 10, 20, 30, 40, 50. That pattern just continues. That's how I'm finding that B. I'm just backing the pattern up. Now, if you get a really weird table where you can't really do that, I'm going to show you in just a minute how to figure out the B in a weird situation like that. But for now, this is going to be kind of how we handle tables for the most part. So the B value for this table is 0. All right, let's do a couple more like this. So I'm going to show you one more together, and then I want you to try a couple on your own. So take a look at this next table. Zoom this. There we go. So in this one, we've got some negative numbers over here, but there's no way for me to pick points that are not negative because all the x or all the y values are negative. So for this, hang on. Okay, so for this one, since we have to deal with the negatives, we've got to think about how when we move from negative 48 to negative 60, we're actually getting more negative. So instead of increasing by 12, which is what it looks like it does, it's actually decreasing by 12. So we call that negative 12. 4 to 5 is still increasing by 1. So to find our slope with that, we got to do negative 12 divided by 1 and get negative 12. So your slope's going to be negative if your table is decreasing as it goes down. The B on this, again, doesn't show. We don't have a spot where the x is 0. But we've got a pretty simple pattern that we can follow back. So I'm at 4. I'm going to go back 3, 2, 1, 0. So if I'm decreasing by 12 going this way, I need to increase by 12 going that way. 12 more than negative 48 is negative 36. 12 more than negative 36 is negative 24. 12 more than that is negative 12. 12 more than that is 0. So my B is 0. Take a minute, pause this video, and then find the slope and the y-intercept for the next two tables. Then come back and see if you were correct. If you've not paused the video, you should pause the video. Okay, hopefully at this point you have unpaused the video and are now back to see if you got the correct answer for these. So for this one, you should have seen that it was decreasing by 8 as this increased by 1. So negative 8 over 1 gives a slope of negative 8. Your B, you would have extended your table back one step because from 1 to 0. So you would have increased this by 8 and got 25. And then in this table over here, when you worked with it, it was a little bit trickier. So from 16 to 6 was a decrease of 10. From negative 9 to 1 was an increase of 10. So you had to do negative 10 divided by 10, and you get a slope of negative 1. And then your b, you could not see b in this table, but we can look for the point that's closest to 0, which would be 1, and we can decide that 0 would be one step back from that. So if your rate of change was negative 1, that means as you move down the table by 1s, your y decreases by 1. So if your y was 6 at 1, you should be able to back that up a step, and it would have been 7 at 0, because that keeps that rate the same. If we go up 1 here, we should go down 1 here if my rate is negative 1. So my b has to be 7. Another option you have on ones like that, especially these that straddle the negatives and positives, you could graph that table in Desmos and create a line from it, and that would show you the place where it touches the y-axis. So that might be an option if you're struggling with how I'm getting that value of 0 in the middle of that table there. All right, and then the next thing we need to be able to do is find slope and y-intercept from 2 points. And this gets a little bit tricky. So to find slope using 2 points, you have to use the slope formula. We've got this formula in our notes earlier, but we're going to write it right here. Go ahead and write yours right here too. So the slope formula says that m is equal to y2 minus y1 over x2 minus x1. And now those 2's and 1's are not exponents. They're just to tell us which x and which y to use in what spot, because the order that we subtract in matters, and we want to make sure that we do that in the correct order. So if I'm going to set this up, I'm going to go ahead and draw out my formula, put my subtraction. And now on top, I need to subtract 2 y's, and on bottom, I need to subtract 2 x's. It may be useful for you, and go ahead and do it on this one, even if you don't think you're going to need it later, to label these as x1 and y1 and x2 and y2. So in your first ordered pair, we have x1 and y1, because there's an x and a y in every ordered pair. And in the second one, we have x2 and y2. So if I want to use those points to find slope, I'm going to plug in the second y minus the first y on top. So the second y is 4, the first y is 0, and I'm going to say 4 minus 0. And then on the bottom, I'm going to say the second x, which is 5, minus the first x, which is 1. And then I'm going to calculate this. Now, you've got options. If you're at school and you've got a graphing calculator like the yellow graphing calculator we use, you can create that fraction bar, put this in, and it will instantly tell you your answer. If you're not, then you're going to need to simplify the top and the bottom first and then divide. So 4 minus 0 is 4, 5 minus 1 is 4, and 4 divided by 4 is 1. So this has a slope of 1. Then we got to find b, and b can get a little bit tricky to find from 2 points. So to find b, if you don't know it from the points that you're given, and the only way we would know it from points we were given is if we knew where the x equaled 0, 0 comma a number. So they don't tell us an x-intercept with one of these 2 points. This point that's 1 comma 0 is not a y-intercept, it's an x-intercept, and I need a y-intercept to be able to find what they're asking me to find. So this is not it. So what we do in that situation to find the b is we take our y equals mx plus b equation, and we substitute values in for the m, the x, and the y, and we leave b in here so I can solve for b. And we'll split the row and we'll be able to solve it. So how do we figure out what to put in for m, x, and y? So to substitute in place of m, I'm going to put what I just found m to be, 1. Now in for x and y, I'm going to pick one of those 2 points from the top. It does not matter which one you use. But whatever you use, you got to use both coordinates from the same point. So I'm going to use 1, 0 because that's really easy for me to work with. So I'm going to put the 1 in for the x. I'm going to put the 0 in for y, because the 1 is the x and the 0 is the y from that point. And again, I'm going to leave the b because that's what I'm trying to find. And I'm going to solve this. So I do 1 times 1 is 1 plus b. And then I subtract 1. And so b is equal to negative 1. And so that's just a simple equation. So my m is 1, my b is negative 1. That gets easier the more we do it. Let's do another one just like it. So here again, I'm going to find slope from 2 points. You always start with finding slope. You cannot find b unless you know slope, unless they tell you b. So to find slope, m equals subtraction, subtraction, always subtraction. So I'm going to put on top the y's. Now again, it might be helpful to you to label them. x1, y1, x2, y2. So I'm going to subtract the second y minus the first. 9 minus negative 3. 3 minus 0. And again, I'm getting all that from here. The second y minus the first one. 9 minus negative 3. 3 minus 0. And I'll calculate. So 9 minus negative 3 is 12. 3 minus 0 is 3. And 12 divided by 3 is 4. That means this has an m of 4. A slope of 4. Now to find b, I can solve for b using my equation, but this problem actually tells me the point that is my y-intercept because it gives me the point where my x is 0. This point right here is the y-intercept. So I don't actually have to solve for b. My b is equal to negative 3. So look for shortcuts like that. Sometimes you get lucky and get a shortcut and not have to solve for b after all. All right, let's do 2 more, and then that'll be the end of our notes on this. So if I set this one up, m is equal to, I'm going to put subtraction, subtraction. So on top is your 2 y's. So again, if it helps, x1, y1, x2, y2. And I'm going to subtract negative 2 minus 5, 9 minus 5. And I get negative 7 over 4. You can leave it as negative 7 over 4, or you can put it as negative 1.75. If it turns out to be a nice pretty decimal, you can leave it that way. If it doesn't, then you're going to want to change that to, or leave it as a fraction. Then I'm going to solve for b. So this one, neither of those points is the b. So to solve for the b, I'm going to have to use that substitution deal. So y equals mx plus b. I'm going to leave b. I'm going to replace m, x, and y. Again, that m gets replaced with what we got for slope up there. Most people are more comfortable with the decimal, so I'm going to use that for m. N for x and y, I'm going to put one of these 2 points. So 5, 5 is probably the easiest one to work with from up there. So I'm going to put 5 in for x, 5 in for y. And then we're going to solve that. So I'm going to do 1.75 times 5, or negative 1.75 times 5. And I get negative 8.75. And then to get b by itself, I just have to add 8.75. And that gives me 13.75 for b. So my b equals 13.75. All right, let's do this one more. Start by finding our slope. Take a minute, pause this, plug this in and see if you can calculate the correct slope. And then see if you can get your b. And then come back and see if you were correct. If you've not paused it, pause it. Okay, hopefully you're back from pausing it. So our y minus y goes on top, 4 minus 0. And then we put 0 minus negative 6 on the bottom is what you should have done. And that's going to give you 4 over 6, which simplifies to 2/3. So m is equal to 2/3. You did not have to solve for b this time. It gave you the point that was b. B is going to be that point where your x is 0. So this point at 0, 4. So your b was 4. All right, that's the end of these notes. Make sure you submit them. And then you'll be set to work on the practice assignments. Thanks. Have a great day.